Hello there, and welcome to the Sleepy Scholar. Tonight's journey takes us into the vastness of space, to the glittering world of our closest star systems. For thousands of years, humanity has looked up from the quiet Earth and wondered about those distant points of light that puncture the velvet darkness of the night sky. They have been our guides for navigation, the gods of ancient myths, and the silent companions to countless sleepless nights, always watching, always burning with a slow and steady patience that defies our hurried sense of time. Tonight, we will leave our own familiar sun behind, drifting outward past the icy edges of our solar system, crossing the immense and silent ocean of interstellar space to visit our nearest celestial neighbors. We will float near red dwarfs that will shine for trillions of years to come. Gaze upon brilliant binary pairs locked in an eternal cosmic dance, and wonder at the lonely worlds that might orbit them in the quiet dark. It is a journey not of speed or urgency, but of drifting peacefully through the infinite, quiet expanse that separates our tiny home from the rest of the galaxy. If you enjoy these quiet explorations, I invite you to like, subscribe, or share a thought below. It helps other curious minds find a place to rest. But for now, get comfortable. Let your eyes grow heavy. Let's begin. Proxima Centauri sits alone in the vast darkness as our nearest stellar neighbor. It is a tiny red ember compared to our own blazing sun, completely invisible to the naked eye despite its relative proximity, silently hiding in the southern constellation of Centaurus, where only telescopes can reveal its faint red glow. It is a red dwarf, the most common type of star in our galaxy, a small and surprisingly densely packed sphere of hydrogen plasma that burns its available fuel with such extreme frugality that it will likely continue to glow steadily for trillions of years, long after our own sun has exhausted itself, swollen into a red giant, and faded into a cooling white dwarf. It orbits its two much larger and brighter siblings, Alpha Centauri A and B, in a grand, incredibly slow loop that takes over 500,000 Earth years to complete just a single time, a timescale so vast that human history feels like less than a fleeting breath in comparison. It stands as a silent, enduring sentinel at the very doorstep of our solar neighborhood, a dim red lighthouse marking the beginning of the deep, unfathomable cosmic ocean that stretches out between the wandering islands of the stars. While Proxima is closest, the brightest stars in that same system are Alpha Centauri A and B, locked together in an eternal shining waltz. To the unaided eye gazing up from Earth's southern hemisphere, they appear as a single brilliant point of light, the third brightest jewel in our entire night sky, acting as a guide for navigators across countless centuries. In reality, they are two magnificent stars, one very similar in size and temperature to our own sun, and the other slightly smaller and cooler, swinging around a common center of gravity in an elliptical orbit that brings them as close as Saturn is to our sun, and then sends them drifting apart out toward the distance of Pluto's orbit. They have been dancing this way for billions of years, their gravitational embrace so tight and perfectly balanced that they will never let go of one another until they both eventually fade into darkness eons from now. Their endless, disciplined circling is a testament to the binding power of gravity, a silent, unseen, and patient force that holds these massive burning spheres together across the cold vacuum of interstellar space. The term closest is a gentle deception when speaking of cosmic distances. We say Proxima Centauri is just over 4 light years away, a number that sounds small enough to almost grasp with our human minds, perhaps like a distance one could travel if given enough time. Yet, if you could travel as fast as a beam of light, a speed so unimaginable it could circle our entire Earth 7 times in a single second, it would still take you more than 4 years of non-stop travel to finally arrive at that distant red shore. If we sent our fastest current spacecraft, Voyager 1, which is already hurtling away from our Sun at nearly 40,000 miles per hour, it would drift through the silent void for over 70,000 years before it finally reached that distant star. The space between stars is a profound and humbling ocean of emptiness, a staggering expanse of almost nothingness that reminds us of the precious rarity of the warm, bright islands we call solar systems. Barnard's star is a solitary wanderer that moves across our sky faster than any other star. Most stars appear fixed in their constellations for centuries, their movements too slow for human generations to notice without the most precise and delicate instruments to track them over decades. But this ancient red dwarf, sitting just 6 light years away in the constellation Ophiuchus, is sprinting through the galaxy relative to our Sun, shifting its position against the background stars by the width of the full moon every 180 years. It is an incredibly old star, perhaps twice the age of our own Sun, traveling on a lonely singular trajectory that will eventually bring it closer to us before it sails off again into the deeper dark. It is a reminder that nothing in the universe is truly still. Even the seemingly eternal and fixed stars are just drifting ships passing each other in the glorious slow-motion ballet of the Milky Way. Hidden just 6.5 light years away is a pair of celestial objects that are neither true stars nor planets, known together as Lumen 16. This system was only discovered relatively recently because its inhabitants are incredibly faint, glowing dimly in infrared heat rather than visible brightness, easily missed by standard surveys of the sky. They are brown dwarfs, sometimes poetically called failed stars, because they formed from collapsing clouds of gas just like stars do, but never gathered quite enough mass to ignite the sustained nuclear fusion that powers our brilliant Sun. Instead, they slowly radiate away the captured heat from their initial formation, cooling gradually over billions of years, like dying embers that never truly caught fire, wrapped in turbulent, exotic clouds of hot mineral droplets, molten iron and silicates condensed into fine, alien rain. They exist in the twilight realm between giant planets and small stars, silent and dim members of our neighborhood that teach us nature does not always fit neatly into the bright categories we create for it. Wolf 359 is one of our nearest neighbors, yet it is so faint that it would take tens of thousands of stars like it to equal the brightness of our own Sun. Located nearly 8 light years away in the constellation Leo, it is a classic example of the most common type of star in our galaxy, the ubiquitous red dwarf. These tiny stars are incredibly numerous, but universally dim, hoarding their fuel so efficiently that they can live for trillions of years, essentially forever in human terms, outlasting almost everything else in the universe. Wolf 359 is so physically small that if it miraculously replaced our own Sun tomorrow, high noon on Earth would be no brighter than standard twilight, casting our entire world into a permanent, dim red dusk. It sits quietly in the dark, a humble, almost eternal ember that will still be glowing faintly long after the brightest and most majestic stars that currently grace our night sky have burned themselves out and faded into mere memories. The star known as Lalande 21185 is one of the brightest red dwarfs visible in our northern skies, though you still need binoculars or a small telescope to find it among the thousands of other faint points of light. It resides in the constellation Ursa Major, the Great Bear, acting as a silent, unseen companion to the famous bright stars of the Big Dipper that we know so well. This star is incredibly old, likely far older than our own solar system. For perhaps 10 billion years, it has been quietly drifting through the galaxy, watching countless other stars be born from nebulae, live their dazzling lives, and die in spectacular explosions while it just keeps glowing. It is currently moving in a way that slowly carries it up and out of the main plane of our galaxy, like a diver rising from a deep cosmic ocean, giving it a unique vantage point as it passes our own neighborhood. Its ancient red light, which takes over 8 years to reach our eyes, carries with it the silent history of a galaxy that has changed profoundly during its long, slow, and steady life. Just beyond the closest red dwarfs lies Sirius, the brightest star in our entire night sky. Known since antiquity as the Dog Star, it has served as a vital calendar marker for ancient civilizations, its heliacal rising once signaling the coming fertile flood of the Nile River in Egypt, bringing life to the desert. At just over 8.5 light years away, it is a true powerhouse compared to our immediate red dwarf neighbors, a main sequence star roughly twice as massive and more than 20 times more luminous than our Sun, burning white hot with ferocious energy. Its brilliance is so intense that on a very dark, clear, moonless night, far from any city lights, its light alone is said to be enough to cast very faint shadows on the ground, a testament to its raw power despite the immense distance. It stands as a dazzling beacon in the winter sky, a brilliant, flashing diamond that reminds us that while most near neighbors are dim, some stars burn with a majestic fury that lights up the void across light years. Hidden in the overwhelming glare of Sirius is a tiny, incredibly dense companion, known affectionately to astronomers as the Pup. For decades, 19th century astronomers noticed Sirius wobbling slightly in its path across the sky, as if it were being gently tugged by an invisible hand, before better telescopes finally revealed this faint partner. Sirius B was once a mighty star itself, perhaps even brighter and more massive than Sirius A is today. But it exhausted its nuclear fuel long ago and collapsed inward into a white dwarf, packing the mass of our entire Sun into a sphere roughly the size of Earth. A single teaspoon of closely packed matter from this incredibly dense stellar remnant would weigh millions of tons if brought to Earth, crushed by gravity millions of times stronger than what we feel on our own planet's surface. It is a stellar ghost, the cooling core of a dead star, endlessly circling its brilliant living partner in a cosmic dance of life and glorious afterlife. The binary system Luton 726-8 contains 2 tiny stars that can suddenly and dramatically change their brightness in mere minutes. Located almost 9 light years away in the constellation Cetus, the Whale. These 2 red dwarfs usually sit quietly in the dark, almost impossible to see without good equipment. However, they are what astronomers call flare stars, possessing intense, tangled magnetic fields that occasionally snap and reconnect with tremendous violence, releasing colossal bursts of energy that can make them several times brighter for just a few short minutes. These stellar tantrums would likely strip away the protective atmosphere of any planet unfortunate enough to orbit too closely, bathing their worlds in sterilizing ultraviolet light before settling back down into a deceptively calm, dim red glow. They remind us that even the smallest, coolest, and seemingly gentlest stars possess a hidden, volatile power, capable of brief moments of fiery fury in their otherwise long and quiet lives. Ross 154 is another of our quiet neighbors that is currently drifting closer to us with every passing year. It lies in the direction of the constellation Sagittarius, appearing against the rich, starry backdrop of the center of our Milky Way galaxy, though in reality, it is vastly closer to us than those distant background stars. Over many tens of thousands of years, it will slowly move a little nearer to our Sun before sailing away again into the endless dark. It is a completely typical red dwarf, representing the silent, unseen majority of our galaxy's population, small, cool, and incredibly numerous, like countless grains of sand on a vast cosmic beach that we only notice when they happen to drift near our own isolated island. Its slow passage is part of the great churning motion of the galaxy, where stars are like ships passing in the night, rarely meeting, but always moving on their own seemingly endless journeys. In the distant future, the title of closest star will pass from Proxima Centauri to the currently obscure star known as Ross 248. Right now, it is just over 10 light years away in the constellation Andromeda, a faint speck that no human eye can see without aid, lost among the more famous patterns of the night. But its trajectory through the galaxy is bringing it directly toward our solar system, and in roughly 33,000 years, it will be closer to us than Alpha Centauri is today. For several millennia, our distant descendants, should they still be watching the skies from Earth or beyond, will look up and know this small red star as their nearest neighbor, before it too continues its majestic, lonely voyage past us and recedes back into the depths of space. It teaches us that the night sky is not a static painting, but a slow-motion movie where the cast of characters is constantly, patiently changing over the eons. Just over 10 light years away lies Epsilon Eridani, a star that offers us a fascinating glimpse into our own sun's distant past. Unlike the ancient red dwarfs that dominate our immediate neighborhood, this star is relatively young, perhaps less than 1 billion years old, still settling down from its chaotic birth in a grand nebula. It is surrounded by vast, dusty debris disks, the leftover remnants of the cloud from which it formed, where comets and icy asteroids are likely colliding frequently, perhaps even now forging new planets in the chaotic crucible of gravity. It spins rapidly on its axis, is highly active with massive magnetic storms, and represents what our own calm middle-aged solar system might have looked like in its tumultuous youth, long before life emerged on Earth. Looking at it is like looking into a cosmic mirror that reflects our own history, showing us the fiery, majestic process of a solar system slowly coming into being. Lacaille 9352 is a small star in the southern sky that is moving with remarkable speed through our neighboring space, while it sits quietly in the constellation Piscis Austrinus, the southern fish. Astronomers have measured its true motion relative to our Sun to be many tens of miles every single second. At this breathtaking velocity, it is one of the faster moving stars known in our immediate neighborhood, a stellar traveler that is just passing through our local volume of space on a long journey. It has already made its closest approach to our solar system thousands of years ago, and is now steadily sailing away from us, its journey taking it onward toward destinations we can only imagine in the far reaches of the galaxy. Its extraordinary speed highlights the dynamic, restless nature of the universe, where everything, even the stars that seem so still, is in a state of majestic, eternal flight. Unlike many of its volatile red dwarf cousins, Ross 128 appears to be an unusually quiet and gentle star. Located about 11 light-years away in the constellation Virgo, it does not seem to have the violent magnetic flares that plague so many other stars of its kind, which often blast their surroundings with radiation. This relative tranquility has made it a prime target for astronomers searching for potentially habitable worlds, as any planets orbiting it might not be constantly bombarded by sterilizing energy, allowing them to retain their atmospheres over billions of years. It drifts slowly through the void, a peaceful, dim haven in a galaxy that can often be violent and unpredictable, offering a stable warmth to whatever silent worlds might be huddled close to its faint red hearth. It stands as a symbol of potential sanctuary in the vastness, a quiet corner of the cosmos where time passes slowly and gently. What looks like a single faint point of light in the constellation Aquarius is actually a remarkable triplet of stars huddled together in the dark. The EZ Aquarii system is located just over 11 light-years away and consists of 3 separate red dwarfs locked in a complex, unending gravitational dance. 2 of these stars orbit each other very closely, completing a year in just a few Earth days, whirling around one another in a tight embrace, while the third star circles this inner pair from a greater distance, watching its siblings spin like tops. Imagine standing on a planet in that system, looking up to see 3 distinct red suns in the sky, casting complex triple shadows and weaving a strange tapestry of day and night that might last for weeks or mere hours. It is a mesmerizing example of nature's preference for company, showing that even in the lonely stretches of interstellar space, stars often find partners for their long journeys. Procyon is the 8th brightest star in Earth's night sky, and its name fittingly translates from ancient Greek as before the dog. It rises just before the brilliant Sirius, the dog star, serving as a celestial herald that announces the imminent arrival of the night's brightest beacon to all who watch the sky. Lying about 11.5 light-years away, Procyon is actually a binary system itself, consisting of a bright, yellow-white subgiant star that is slowly beginning to swell as it ages, and a tiny, faint white dwarf companion that was once a larger star itself. They orbit each other every 40 years, an uneven pair where the dead remnant of one star silently circles the slowly aging brilliance of the other, a reminder of the inevitable life cycle that awaits all stars. They dance together through the eons, a bright living star and its ghostly partner, marking the passage of cosmic time with their slow, steady waltz. The star 61 Cygni in the constellation Cygnus holds a special place in the history of human understanding of the cosmos. Known historically as Piazzi's flying star, due to its relatively rapid motion across the sky, it was the very first star, other than our own sun, to have its distance successfully measured by astronomers in the 19th century. By carefully observing its tiny apparent shift against the background of more distant stars as Earth moved around the sun, a phenomenon known as parallax, they calculated it was roughly 11 light-years away, finally giving humanity a true sense of the staggering scale of the universe. It shattered the ancient, comforting idea of a fixed sphere of stars just beyond the planets, revealing instead a universe of unimaginable depth and terrifying vastness. It was the key that unlocked the true, majestic depth of the night sky, turning a two-dimensional dome into an infinite, three-dimensional ocean of space. Groombridge 34 is another binary pair of red dwarfs, located nearly 12 light-years away in the northern constellation of Andromeda. These two stars are separated by a vast distance, orbiting each other so slowly that it takes nearly 3,000 Earth years for them to complete a single revolution around their common center. If you lived on a planet orbiting one of them, the other would appear only as a very bright star in the night sky, not a second sun, perhaps serving as a brilliant North Star for civilizations that might rise and fall without ever knowing they were actually part of a binary system. They are drifting together through space, loosely bound by gravity but forever linked, like two distant ships sailing the same course across a boundless dark sea. Their tenuous connection across such a vast distance is a testament to the far-reaching, gentle yet unbreakable grip of gravity. Epsilon Indi is a star visible to the naked eye in the southern sky, an orange dwarf slightly smaller and cooler than our own Sun. Located just under 12 light-years away, it was long thought to be a solitary star until very recently, when precise observations revealed it has distant companions hiding in the dark. It is orbited not by other stars, but by a pair of brown dwarfs, those strange failed stars that never ignited, which circle it from a tremendous distance, much further out than Pluto is from our Sun. These dark, cooling worlds wander the frozen outer reaches of that system, too massive to be planets, but too small to be stars, forever destined to be the dim, silent attendants to their bright, orange parent star. The system paints a picture of a lonely, warm hearth in the center of a vast, cold expanse, with only fading embers for company in the deep outer dark. DX Cancri is a small and fragile-looking star that sits just under 12 light-years from our own solar system. It is a red dwarf, like so many of our neighbors, but it is near the very bottom of the scale for what can actually be considered a star, possessing just enough mass to sustain the fusion reactions that make it shine. If it were only slightly smaller, it would have failed to ignite entirely and remained a dark, cooling brown dwarf, forever hidden in the blackness of space without ever producing its own light. Instead, it glows with a tenuous, flickering red light, a borderline object that balances delicately between being a true star and a mere accumulation of cold gas. It is a reminder of how subtle the difference can be between a radiant sun and a dark, silent world, existing on the very edge of stellar possibility. Tau Ceti is the nearest single star that is truly similar to our own Sun in both temperature and brightness. Located just under 12 light-years away in the constellation Cetus, it has long captured the imagination of dreamers and scientists alike because it looks so familiar to us, a steady yellow-white anchor in a sea of alien red dwarfs. Unlike many stars, it appears unusually stable and quiet, lacking the violent variability that might threaten any worlds huddled around it, making it a peaceful harbor in the often tumultuous stellar ocean. It is surrounded by a massive disk of dust and debris, far larger than our own Kuiper belt, suggesting a system that is perhaps still settling down, where comets and asteroids dance in vast numbers around its calm, steady light. It represents a kind of cosmic twin to our home, a familiar face gazing back at us across the frighteningly vast gulf of interstellar space. Hidden in the southern constellation of Horologium is GJ1061, a star that went largely unnoticed for decades despite being our 20th nearest neighbor. It is another dim red dwarf, sitting about 12 light-years away, and for years it was just another anonymous entry in vast stellar catalogues, assumed to be lonely and uninteresting. Recently, however, astronomers discovered it is likely harboring a system of multiple planets, some of which might reside in its habitable zone where temperatures could allow for liquid water. It is a profound realization that even the most seemingly unremarkable and overlooked stars in the quiet dark might be host to entire worlds, silent stages where unknown dramas of geology or perhaps even life could be unfolding right now, completely unbeknownst to us. It teaches us that there are no boring stars in the sky, only those we have not yet watched closely enough to learn their secrets. YZ Ceti is a small red star that is remarkably close, in galactic terms, to Tau Ceti, our sun-like neighbor. Though they are not gravitationally bound to each other, they are currently drifting through the same region of the galaxy, separated by only a couple of light-years, a short hop on cosmic scales. If you stood on a planet orbiting YZ Ceti, Tau Ceti would be a brilliant object in your night sky, far brighter than Sirius appears to us on Earth, perhaps even visible during the day like a distant, second miniature sun. These two very different stars, one tiny and red, the other bright and yellow, are like two strangers briefly sharing a train car on a long journey, momentarily close before their varying speeds inevitably pull them apart again. It is a fleeting cosmic meeting that will last for mere millennia before the endless drift of the galaxy separates them forever. Luyten's star is named after the patient astronomer who first noticed its rapid motion across the photographic plates of the night sky. Located just over 12 light-years away in the constellation Canis Minor, it is a very common type of red dwarf, but it is special to us because it hosts a super-Earth planet known as Luyten b within its habitable zone. This distant world sits at just the right distance from its dim red sun to potentially have lakes or oceans of liquid water on its surface, bathing under a permanent ruddy twilight. It is one of the most promising nearby targets for future generations to study, a tantalizing hint that comfortable, Earth-like environments might not be rare miracles, but common features of our local stellar neighborhood. It waits there in the quiet dark, a potential sister world warmed by a different, older, and redder sun than our own. Teegarden's star is an ultra-cool dwarf that was only discovered in the 21st century despite being just 12.5 light-years away. It is so incredibly dim and red that it evaded all the great telescopic surveys of the 20th century, hiding in plain sight because it emits almost all of its meager energy as invisible infrared heat rather than visible light. It is an ancient star, likely twice the age of our own solar system, having quietly existed for perhaps 8 billion years, while civilizations rose and fell on Earth without ever knowing it was there. Its late discovery is a humbling reminder of how much we still have to learn about even our own celestial backyard, and how many silent, invisible neighbors might still be lurking undetected in the shadows just beyond our current vision. It is a testament to the quiet, unassuming endurance of the smallest things in the universe. Captain's star is a true galactic visitor that is just passing through our local solar neighborhood. Located nearly 13 light-years away, it is a halo star, born not in the majestic spiral disk of the Milky Way like our Sun, but likely in a dwarf galaxy or ancient cluster that was long ago consumed and ripped apart by our own galaxy's immense gravity. It is incredibly old, perhaps 11 billion years of age, originating from a time when the universe itself was vastly different than it is today, and it is zooming past us backwards relative to most other stars. It is an ancient traveler from a lost world, a stellar refugee carrying the chemical fingerprints of a long-dead galaxy, briefly sharing our space before it continues its lonely, eternal exile through the halo of the Milky Way. It brings a touch of unbelievably deep time to our immediate surroundings, a wandering artifact from the dawn of the cosmos. Lakar 8760 is technically the brightest red dwarf visible in Earth's sky, although bright is a relative term for these dim stars. While it still requires a small telescope or very good binoculars to be seen by human eyes, it is intrinsically far more luminous than neighbors like Proxima Centauri or Wolf 359. Located nearly 13 light-years away, it sits on the very upper boundary of what can be considered a red dwarf, almost massive enough to be a larger orange star. Because of its larger size, it is less turbulent than its smaller kin, shining with a steadier, calmer light that lacks the violent, unpredictable flaring common to tinier stars. It is a placid, stable neighbor, a quietly burning ember that has found a peaceful equilibrium, steadily radiating its warmth into the cold void without drama or fury. Kruger 60 is a binary pair of red dwarfs that orbit each other relatively quickly compared to many other wide pairings, located about 13 light-years away in the constellation Cepheus. These two small stars circle their common center of gravity roughly every 44 years, a period short enough for a single human being to watch nearly an entire orbit over the course of their lifetime. Astronomers have watched them dance since the 19th century, tracing their neat elliptical paths as they swing close together, and then drift further apart in a predictable, endless celestial waltz. They are a perfect piece of cosmic clockwork, keeping time on a grand scale, their movements as reliable and steady as the turning of the Earth itself, unbothered by the chaos of the galaxy around them. They remind us of the beautiful, silent precision that governs the motions of even the most massive objects in the universe. Ross 614 is a binary system that was first detected not by seeing both stars, but by watching one star wobble. For years, astronomers tracking the primary red dwarf noticed it was tracing a strange, wavy path across the sky instead of a straight line, betraying the presence of an unseen, dimmer companion tugging on it with gravity. It took powerful new telescopes to finally visually separate the two stars, revealing a very faint secondary red dwarf that had been hiding in the glare of its slightly brighter partner. It is a classic example of how gravity allows us to see the invisible, feeling the presence of hidden objects by their gentle influence on the things we can see. It is a reminder that in space, nothing truly moves alone. Every object is feeling the silent, insistent pull of its neighbors in the dark. Van Maanen's star is the closest solitary white dwarf to our own solar system, sitting just over 14 light-years away. It is not a living star fueled by fusion, but the slowly cooling, intensely dense core of a dead star that was once likely very similar to our own sun. Billions of years ago, it exhausted its fuel, blew off its outer layers to form a beautiful but fleeting nebula, and left behind this Earth-sized sphere of degenerate matter that will slowly fade over trillions of years. It is a stellar ghost, a silent prophecy of our own sun's eventual fate, sitting quietly in the dark as a monument to a star that once shone brilliantly, long before humanity ever existed. It is a graveyard of one, a solemn and enduring remnant of a majestic life that has long since ended. Gliese 876 is a red dwarf that provided one of the first true shocks in the hunt for exoplanets. Located about 15 light-years away, it was found to host not just one, but multiple massive Jupiter-sized planets orbiting incredibly close to the star, far closer than Mercury is to our Sun. Before this discovery, scientists believed giant planets could only exist in the cold outer reaches of star systems, just like our own Jupiter and Saturn. This system shattered those assumptions, showing us that solar systems can be wildly different from our own, with giant worlds huddled close to their varied suns for warmth. It opened our eyes to the marvelous diversity of the galaxy, proving that nature is far more creative in arranging worlds than our own limited experience had led us to believe. Gliese 687 is a quiet red dwarf located in the constellation Draco, the Dragon, nearly 15 light-years from Earth. It is notable precisely for how unremarkable it is. It is a calm, steady, run-of-the-mill star that simply drifts through space without violent flares or unusual characteristics. It has a Neptune-mass planet orbiting silently around it, a frozen world that likely resembles a giant icy marble, rolling forever through the dark. Stars like this are the silent majority of our galaxy, the quiet, stable, average citizens of the Milky Way that make up the bulk of its stellar population. They don't draw attention to themselves with spectacular displays, but their very stability and countless numbers form the enduring backbone of our galactic home, burning steadily while brighter, shorter-lived stars flash and fade around them. Gliese 674 is a nearby star that is surprisingly young compared to many of its ancient red dwarf neighbors. At perhaps only a few 100 million to around 1 billion years old, it is a relative toddler in stellar terms, still spinning more rapidly than older, more sedate stars. This fast rotation generates powerful magnetic fields, making the star highly active with star spots, vast, dark, cool regions on its surface that are far larger than any sunspots seen on our own sun. As it rotates, its brightness dips measurably every few weeks when these massive spots turn toward us, like a lighthouse with a smudged lens slowly sweeping its beam across the cosmos. It gives us a glimpse into the energetic, turbulent youth that all stars must pass through before they settle down into the long, quiet maturity of their middle age. Voyager 1, the farthest human-made object from Earth, is currently sailing silently toward a modest red dwarf known as Gliese 445. Located about 17 light-years away in the constellation Camelopardalis, this star is currently drifting closer to our solar system. In about 40,000 years, long after Voyager's power sources have died, and it has become a frozen, silent derelict, it will make its closest pass to this star, though it will still be over a light-year away from it. It is a poignant rendezvous in the incredibly distant future, a meeting between a tiny, dead ambassador from Earth and a star that doesn't even know it is coming. It is a testament to the immense timescales of interstellar travel, where even our fastest messengers take eons to bridge the silent gulf between the stars. Wolf 1061 is a red dwarf about 14 light-years away that hosts a particularly interesting system of planets. The middle planet, Wolf 1061c, sits squarely within the star's habitable zone and is one of the closest potentially rocky worlds to us that might have a stable atmosphere. Because it orbits a dim red star, its year is only about 18 Earth days long, meaning it is likely tidally locked, with one side perpetually facing the star in endless day and the other frozen in eternal night. Between these two extremes, along the twilight strip that forever circles the planet, there might exist a temperate zone of perpetual evening where life could theoretically find a foothold. It paints a picture of a strange, alien world of permanent shadows and eternal ruddy sunsets, a vastly different kind of home than our own spinning blue marble. The closest star systems are not just distant points of light. They are intermingled with the outer edges of our own home. The Oort cloud, a vast theoretical sphere of trillions of icy comets that surrounds our Sun, is thought to extend perhaps a light year from the Sun, only a small fraction of the way to the nearest stars like Proxima Centauri, but still unimaginably far beyond the planets. This means that the gravitational influence of our Sun gently hands off to the gravity of our neighbors in the deep, frozen dark between them, with no firm border or signpost marking the edge. Occasionally, a passing star like Schultz's star can graze this outer cloud, disturbing these ancient icy bodies and sending them slowly tumbling inward toward the inner solar system as long-period comets. We are not truly isolated in a bubble. We are part of a continuous overlapping tapestry of gravitational fields, where the wispiest outer edges of our home brush against the outer edges of others. GJ1214 is a red dwarf that hosts one of the most intriguing types of worlds we have ever discovered. The planet, GJ1214b, often called a water world, is larger than Earth but smaller than Neptune, and some models suggest it might be covered entirely by a global ocean or enveloped in a thick, water-rich atmosphere, with layers of exotic high-pressure ice deep below. Beneath that crushing, deep envelope, forms of ice that are hot but solid due to the immense weight above them might make up the planet's strange mantle. It is a world completely unlike anything in our own solar system, a vast, warm, cloud-wrapped world orbiting silently in the red twilight of its parent star. It expands our imagination of what a planet can be, showing us that the universe is capable of creating worlds that are almost purely made of ocean and vapor. Many stars we see as single points of light are actually complex families, like the System 40 Eridani. Located just over 16 light-years away, it contains 3 stars, a bright orange dwarf, a dim red dwarf, and a dying white dwarf, all bound together in a complex, widely spaced gravitational dance. It is famous in science fiction as the fictional location of the planet Vulcan from Star Trek, but in reality, it is a fascinating example of stellar diversity, containing 3 very different types of stars, all born from the same original cloud. They offer a unique laboratory for astronomers, allowing them to study 3 different stages of stellar life: middle-aged, old, and dead, all in one single convenient cosmic package. It is like a family portrait that simultaneously shows the varied, inevitable stages of life that all stars must eventually experience. Just over 8 light-years away lies GJ411, also known historically as Lalande 21185, which we visited earlier, but it is worth revisiting for its role as a persistent mystery. For decades, astronomers have debated whether it has planets, with potential detections appearing and then vanishing as instruments improved. It represents the very edge of our current ability to see, a star that sits right on the threshold of revealing its secrets, teasing us with hints of worlds that might or might not be there. It is a reminder that science is a slow, patient process of refining our vision, where truths often emerge only after years of careful, quiet watching in the dark. It stands as a symbol of the unknown that still permeates even our closest celestial neighborhood, waiting patiently for us to build better eyes to see it clearly. Stein 2051 is a binary system located about 18 light-years away that recently helped astronomers confirm one of Einstein's most famous theories. The system contains a bright red dwarf and a much fainter white dwarf, the dense corpse of a dead star, which happened to pass directly in front of a more distant background star from Earth's perspective. As it passed, the immense gravity of the tiny white dwarf actually bent the light from the distant star around it, acting like a cosmic magnifying lens and causing the background star's apparent position to shift ever so slightly. This delicate measurement, taken a century after Einstein first predicted such an effect was possible, allowed scientists to weigh the white dwarf with incredible precision by seeing how much it warped the fabric of space-time around itself. It is a beautiful demonstration that even the quietest, deadest remnants of stars still possess the majestic power to bend the very path of light as it travels through the dark. Gliese 710 is a currently unremarkable star that is destined to become the most important object in humanity's future night sky. Right now, it is a dim speck about 62 light-years away, far beyond what we usually consider our immediate neighborhood, but it is hurtling directly toward us at high speed. In about 1,300,000 years, a vast expanse of time for us, but a mere moment to the galaxy, it will pass within the outer edges of our own solar system, shining brilliantly as a new, bright orange-red star in the night. Its gravity will gently strum the outlying Oort cloud of comets like a cosmic harp, sending a slow-motion shower of icy visitors tumbling toward the inner sun over the subsequent millions of years. It is a future appointment that is already written in the stars, a grand slow-motion celestial encounter that is steadily approaching across the ages. Hidden in the deepest darkness just 7 light-years away is WIS E0855, an object that challenges our very definition of what a star can be. It is a brown dwarf, but it is so incredibly cold that if you could somehow descend to where its atmosphere becomes thick and opaque, you would not burn, but rather freeze instantly, as its temperature is similar to the icy poles of Earth. It is a frozen star, having lost almost all the heat from its formation billions of years ago. Now just a dark, Jupiter-sized sphere of incredibly cold gases, drifting silently through the blackness between brighter suns. It likely has turbulent clouds of frozen water and ammonia in its atmosphere, making it more like a gigantic, free-floating planet than a star, blurring the lines between the two in a fascinating way. It reminds us that interstellar space is not just filled with fiery suns, but also with cold, dark, lonely worlds that will never know the warmth of a parent star. Our entire solar system, along with many of our nearest stellar neighbors, is currently drifting through a vast, tenuous cavern in space, known as the local bubble. This is a gigantic region of the Milky Way's interstellar medium that is surprisingly empty, cleared out millions of years ago by titanic supernova explosions that swept away the denser clouds of gas and dust like a cosmic broom. We are effectively floating in a quiet, clear clearing within the grand, dense forest of the galaxy, which allows us a much clearer view of the distant universe than we might otherwise have. The walls of this bubble are hundreds of light-years away, where the denser gas has piled up, forming regions where new stars are now being born from the debris of those ancient, majestic detonations. It is a reminder that calm spaces in the universe are often carved out by the grand, energetic events of the deep past. A D Leonis is a seemingly innocent red dwarf located about 16 light years away in the constellation Leo that is actually one of the most powerfully active stars in our vicinity. It is a flare star that is in a near constant state of magnetic turmoil, frequently unleashing colossal eruptions of energy that are vastly more powerful than any solar flare ever recorded from our own sun. These majestic magnetic storms would bathe any nearby planets in intense ultraviolet light and charged particles, likely stripping away their atmospheres and rendering them barren rock. Yet from our safe distance, they are merely fascinating flickers in a telescope. It spins rapidly, a sign of its vibrant stellar youth, and its violent weather is a stark contrast to the steady, life-giving calmness of our own middle-aged sun. It serves as a dramatic laboratory for understanding the volatile environments that many young planets must endure in their early epochs. When we listen to our nearest stellar neighbors with powerful radio telescopes, we are met with what is poetically known as the Great Silence. For decades, astronomers have pointed their most sensitive ears towards stars like Tau Ceti and Epsilon Eridani, hoping to catch the faint whisper of an artificial signal, a hum of technology from another civilization. But they have heard only the natural static of stellar processes. This profound quiet does not necessarily mean we are alone. It might simply mean that distances are too vast, civilizations too fleeting, or their technologies too different for us to hear across the cosmic ocean. It turns our immediate neighborhood into a seemingly pristine, uninhabited wilderness, a vast frontier of silent worlds waiting for us to one day perhaps visit them ourselves. The silence is not empty. It is a heavy, pregnant stillness filled with infinite possibility and unanswered questions. 70 Ophiuchi is a dazzling binary system just under 17 light years away that would be a stunning sight to behold up close. It consists of a bright orange star and a slightly dimmer, redder companion that orbit each other every 88 years in an elongated path that brings them relatively close and then swings them far apart. Seen from a hypothetical planet, these two suns would bathe the world in a strange, shifting double light of gold and ruby, their separation in the skies slowly changing over the course of a human lifetime. They have been watched by astronomers since the late 18th century, their slow, graceful waltz around each other, providing one of the first clear proofs that Newton's laws of gravity operated perfectly even outside our own solar system. They are a beautiful, colorful pair of jewels, locked together forever in the dark velvet of space. Gliese 581, located about 20 light years away, was one of the first star systems to truly ignite humanity's hope of finding Earth-like worlds nearby. It is a red dwarf that is famed for having a complex system of multiple planets, several of which have, at various times, been considered potential candidates for hosting liquid water on their surfaces. While scientific debate continues about the exact conditions on these worlds, the system stands as a monumental landmark in our exploration. The first time we found a solar system that vaguely resembled the complexity of our own, with rocky worlds tucked into warm orbits near their star. It changed the question from, "Are there other Earths?" to merely, "Where are they?" Shifting our perspective from hopeful speculation to a concrete search for tangible places. It remains a beacon of possibility in the Libra constellation, a hint of the crowded, diverse cosmos that awaits us. Delta Pavonis, located just under 20 light years away, offers us a fascinating glimpse into our own sun's inevitable future. It is a solar analog, a star very similar in mass and composition to our own Sun, but it is significantly older, perhaps nearing the end of its steady hydrogen-burning life and preparing to slowly swell into a subgiant. By studying it, astronomers can see what our own solar system might look like in a few billion years, observing the gentle, slow brightening that comes with advanced stellar age. It is like looking at an older sibling of our Sun, a calm and steady star that has nurtured its surroundings for eons and is now entering the dignified twilight of its long main sequence life. It stands as a quiet reminder that stars, like living things, have distinct life stages, each with its own tranquil beauty. The system SCR 1845-6357 is a remarkable binary located about 12 light-years away, featuring a very tight pairing of a red dwarf and a brown dwarf. The two objects are incredibly close to each other, orbiting at a distance roughly equal to that between our Sun and Jupiter, which is quite intimate in stellar terms. The primary red star is dim, but its companion is even fainter, a borderline object that barely glows with its own fading heat, forever huddled close to the meager warmth of its slightly larger partner. It is a system of deep shadows and faint red light, where a day on any moon orbiting the brown dwarf would be illuminated by a sun that looks more like a bright, angry red eye than a true star. It showcases the diverse and sometimes tenuous relationships that objects can form in the cold depths of space. Gliese 1002 provides a perfect example of how treasures can remain hidden in data we already possess. Located less than 16 light-years away, this quiet red dwarf was recently discovered to host two planets with Earth-like masses sitting perfectly within its habitable zone. These worlds were not found by new telescope observations, but by carefully reanalyzing years of older data with more advanced techniques, revealing the subtle wobbles caused by these planets that had previously been missed. It is a stunning realization that habitable worlds might already be sitting in our archives, just waiting for us to become clever enough to see their faint signatures hidden in the noise. It teaches us that discovery is often not about looking further, but about looking more deeply and understandingly at what we have already seen. Interstellar space is not just empty voyaging. It is sometimes crossed by visitors that were born around our neighboring stars. Objects like Oumuamua and Comet Borisov, which recently passed through our solar system, are likely debris ejected from other star systems, perhaps from one of our near neighbors, sent drifting through the galaxy for millions of years before briefly crossing our path. These silent, tumbling messengers are physical pieces of other solar systems that we can actually study up close, offering us a tangible connection to the distant worlds we can only see as points of light. They remind us that while stars are islands, they slowly trade material over the boundless eons, sharing their history in the form of frozen, wandering rocks. We are all part of a grander, interconnected ecosystem of debris that slowly cycles through the Milky Way. LP 890-9 is a tiny, ultra-cool dwarf star located just over 100 light-years away, a bit further than our immediate neighbors, yet highly relevant to our understanding of them. It hosts two super-Earth planets that orbit incredibly quickly, with years lasting just a few Earth days, meaning they are huddled extremely close to their dim, cool parent star for warmth. Despite this closeness, the star is so faint that these planets might still be temperate enough to host liquid water, huddled around their glowing red ember like campers around a dying fire in a vast, cold wilderness. It is a prime target for our newest giant telescopes to sniff their atmospheres for signs of life, representing one of our best chances to taste the air of another world in the coming decade. It shows that even the faintest stars can be rich with potential. 61 Virginis is a star located about 28 light-years away that is remarkably similar to our own Sun, just slightly less massive and a bit dimmer. It is considered one of the most stable stars in our neighborhood, lacking the violent flare activity of red dwarfs and providing a calm, steady bath of light to its surroundings for billions of years. We know it has a massive debris disk of dust and at least a couple of known planets. Though they are hot, Neptune-sized worlds that likely aren't hospitable to life as we know it. Nevertheless, it stands as a reassuringly familiar anchor in the night sky. A steady yellow-white sun that proves our own home star is not entirely unique, but just one of many stable, long-lived hearths scattered through the dark. HN Pegasi is a young sun-like star located about 60 light-years away that is still shaking off the dust of its recent creation. It is only about 300 million years old, a mere infant compared to our middle-aged sun, and it spins rapidly, brimming with the energetic restlessness of youth. It is surrounded by a bright, warm disk of dust, a remnant of the majestic cloud from which it recently collapsed, where asteroids and comets are likely colliding constantly in a chaotic, creative flurry that might be forging future planets. Watching it is like looking through a time machine at our own solar system during its tumultuous early days, before life began, when the Earth was still being heavily bombarded by the leftover debris of its formation. It is a snapshot of a solar system under construction, a majestic work in progress. Altair is one of the brightest stars in our night sky and a relatively close neighbor at just under 17 light-years away. It is famous for its incredible rotation speed. It spins so violently fast that a complete day on Altair lasts only about 9 or 10 hours, compared to our Sun's 25 days. This ferocious spinning causes the star to bulge outward significantly at its equator, making it look less like a perfect sphere and more like a squashed, glowing egg, with its poles being much hotter and brighter than its stretched-out middle. It is a star living life in the fast lane, a brilliant, distorted, rapidly rotating powerhouse that demonstrates the incredible physical forces at play in the cosmos. Forces capable of warping the very shape of a massive sun. Most stars do not travel alone through the galaxy, but move together in vast, loose families known as stellar associations. Many of the stars in our sky, including some of the bright ones in the Big Dipper, are actually siblings that were born from the same massive nebula hundreds of millions of years ago and are still drifting through space on parallel paths like a dispersed flock of birds. Though they may now be separated by dozens of light years, they share a common motion and chemical composition that betrays their shared origin in a long dissipated cosmic nursery. It is a beautiful thought that stars, like people, often have distant families they travel with, silently sharing a heritage even as they live out their solitary lives, separated by the immense gulfs of space. EQ Pegasi is another nearby binary system, located about 20 light-years away, consisting of 2 red dwarfs that are both wildly active flare stars. They are currently moving closer to each other in their mutual orbit, a slow-motion approach that will see them reach their closest point in the coming decades before swinging apart again. These 2 volatile, moody stars occasionally brighten dramatically as magnetic storms rip across their surfaces, signaling to each other across the dark gap between them with flashes of intense energy. They are like two flickering, untamed candle flames in a dark room, their unsteady light a testament to the dynamic, ever-changing nature of the active universe we inhabit. Groombridge 1618 is an orange-red dwarf located just under 16 light-years away in the constellation Ursa Major. It is a K-type star, which means it sits happily in the Goldilocks zone of stellar classification. Bigger and brighter than the tiny red dwarfs, but smaller and longer-lived than our own Sun. These types of orange stars are considered by many astronomers to be perhaps the most perfect hosts for life, as they are stable for tens of billions of years, offering their planets a profoundly long, steady, and gentle window of time in which to evolve. It is a quiet, unassuming star that might, in the very long run, prove to be a far better cradle for life than our own brighter, faster-burning Sun. It represents the gentle middle path of stellar evolution, neither too hot and fleeting, nor too cool and volatile. Perhaps the most profound fact about our closest neighbors, particularly the red dwarfs like Proxima and Barnard's star, is their almost eternal nature. While humanity frets over years and centuries, these small, steadily burning stars have lifespans measured in trillions of years, thousands of times longer than the current age of the entire universe. Long after our own Sun has died and turned into a cold crystal in the dark, and long after the Milky Way has collided with Andromeda and settled into a new shape, these tiny red neighbors will still be there, barely having aged, glowing steadfastly in a vastly changed cosmos. They are the true inheritors of the universe, silent, patient witnesses that will watch the grandest eras of cosmic history slowly unfold while they merely sip at their immense reserves of fuel. Fomalhaut is one of the most poetically distinct stars in our neighboring sky, often referred to as the Lonely One, because it sits in a relatively empty region of the southern autumn heavens. Located about 25 light-years away, it is a young, intensely bright white star that is burning through its fuel at a ferocious, youthful pace. What makes it truly majestic is the colossal ring of coal dust and icy debris that surrounds it, a perfectly circular cosmic halo that is billions of miles wide. In telescope images, this vast, glowing ring, with the bright star perfectly centered inside it, looks eerily like a giant, celestial eye staring back at us from the deep dark of space. It is a young solar system in the throes of creation, a massive, messy, beautiful workshop where planets are likely still coalescing out of the raw, icy material of that grand, encircling ring. Vega, glowing brilliantly about 25 light-years away in the constellation Lyra, is destined to play a very special role in Earth's own distant future. Because our planet wobbles very slowly on its axis like a spinning top that is just beginning to lose its momentum, a cycle that takes about 26,000 years to complete, our North Pole points to different stars over vast stretches of time. Right now, it points to Polaris, but in about 12,000 years, it will point steadily toward brilliant Vega, making it our new North Star. It has held this prestigious title before, countless millennia ago, when mammoths still walked the icy plains of Earth, and it will hold it again long after we are gone, a silent testament to the grand, slow, repetitive clocks that govern the movements of our world. It is a reminder that even the most fixed and certain things in our sky, like the North Star, are actually temporary markers in a ceaselessly shifting cosmos. Castor, one of the twin stars of Gemini, appears to the naked eye as a single, bright white point of light, just 51 light-years away. However, it is actually one of the most complex and crowded stellar families we know of, a majestic sextuple system. It consists of 6 individual stars, all bound together by gravity, organized into 3 different pairs that are all waltzing around a common center in a profoundly intricate gravitational ballet. Imagine a sky with 6 different suns, 4 bright, hot white ones that would cast stark, sharp shadows, and 2 dim red embers glowing faintly in the background. It is a dazzling example of nature's tendency to organize matter into complex hierarchies, a magnificent stellar chandelier hanging in our immediate galactic neighborhood that defies standard expectations of what a star is. Pollux is the closest giant star to Earth, located about 34 light-years away in the same Gemini constellation as Castor. It is an orange giant, a star that has already exhausted the hydrogen in its core and has swollen up to nearly 10 times the size of our own Sun, glowing with a warm, steady autumnal light. Looking at Pollux is like looking into a crystal ball that shows us the inevitable future of our own Sun, which will also one day swell into a similar giant in billions of years, swallowing Mercury and Venus in its fiery expansion. Pollux stands now as a gentle, bloated, older star, having lived a long life and now entering its final majestic phase of existence before it eventually puffs its outer layers away into the dark to become a faint white dwarf. The TRAPPIST-1 system, though slightly further out at about 40 light-years, is perhaps the most harmonious solar system we have ever discovered. It is a tiny, ultra-cool red dwarf orbited by 7 Earth-sized worlds, all huddled incredibly close to the star, closer than Mercury is to our Sun. What is truly beautiful is that these planets are in perfect orbital resonance with each other. For every 8 times the closest planet orbits, the next one orbits exactly 5 times, the next one 3, and so on, creating a complex, rhythmic celestial music that has remained stable for billions of years. If you stood on one of these worlds, the other planets would appear as large, visible disks in the sky, sometimes looking larger than our moon, passing each other in a grand, silent, unending clockwork dance. It is a system of profound order and delicate balance, a masterpiece of gravitational engineering. The space between the stars is not entirely empty. Our solar system is currently drifting through a wispy region known as the local interstellar cloud. It is a vast, incredibly tenuous puff of gas and dust that spans roughly 30 light-years, so thin that it is almost a perfect vacuum by laboratory standards on Earth. We have been sailing through this gentle cosmic fog for the last few tens of thousands of years, and its incredibly faint particles are constantly streaming into our solar system, pushed aside only by the magnetic bubble of our own Sun. It is a reminder that we are not just traveling through empty blackness, but are rather like a submarine moving through a very deep, very clear, but still substantive ocean of varied textures and densities. We are currently passing through a gentle current in that great galactic sea. Arcturus is a bright orange giant that is currently passing through our stellar neighborhood, but it is not truly one of us. Located about 37 light-years away, it is a visitor from the galactic halo, a much older generation of stars that typically orbits the galaxy high above the main spiral disk where we live. It is currently plunging down through our galactic plane like a diver cutting through the surface of the water, and in a few 100,000 years, it will have passed through and continued its lonely journey into the depths below us. It is an ancient traveler, likely billions of years older than our own sun, just passing by our windows for a brief cosmic moment before vanishing back into the grander, older structures of the Milky Way. Deep beyond all these closest stars, pulling on them and us alike, is a mysterious, massive region of gravity known simply as the Great Attractor. While not a star system itself, it is the grand destination toward which our entire local neighborhood of stars, including Alpha Centauri, Sirius, and our own sun, is slowly streaming at millions of miles per hour. We are all part of a vast river of stars flowing across the universe toward this unseen gravitational valley, bound together by forces on a scale that dwarfs individual solar systems. It is a humbling thought that even as our stars drift randomly relative to each other, we are all collectively on a much grander journey together, pulled by immense, silent currents that span hundreds of millions of light years across the cosmos. There is a profound concept in astronomy known as the sphere of human radio, which is currently only about 100 light years in radius. This means that only the very nearest stars we have discussed, Proxima, Sirius, Vega, and their immediate neighbors, have had enough time to potentially hear our very earliest, faintest radio and television broadcasts, which have been traveling away from Earth at the speed of light since the 20th century. To the rest of the immense galaxy, we are still completely silent and invisible, our noisy arrival on the cosmic stage not yet announced by the slow-moving messengers of light and radio. We live in a quiet bubble of our own making that is slowly, very slowly, expanding into the ancient silence of the stars around us. Binary sunsets, like the famous fictional one in Star Wars, are a very real and likely common phenomenon in our stellar neighborhood. In systems like 70 Ophiuchi or Alpha Centauri, a planet could experience days with two distinct shadows, and twilights where one sun sets while the other is still in the sky, painting the clouds in complex, overlapping colors of red, orange, and yellow. Depending on the planet's orbit, there might be seasons where night never truly comes, because as one sun dips below the horizon, the other is just rising, bathing the world in a perpetual shifting state of daylight. It is a marvelous reminder that the simple, singular rhythm of day and night we know on Earth is just one of countless possible variations on the theme of time in our galaxy. Zeta Reticuli is a wide binary system located about 39 light years away that is famous in modern folklore, but fascinating in reality for its similarity to us. It consists of two yellow stars, both very similar to our own sun, that are widely separated by a distance of many billions of miles, allowing them to be stable individual systems while still being bound together. If a civilization existed there, they would have a bright companion star in their night sky that would be easily visible even during the day, a constant reminder that another sun, perhaps with its own worlds, was just a relatively short voyage away. It is a system that naturally invites dreams of easy interstellar travel, offering two separate warm home fires in the same close corner of the dark. Every star, including our own, sits inside a vast bubble of its own making, known as an astrosphere. Our sun blows a constant wind of charged particles outward, which pushes against the thin gas of interstellar space, creating a gigantic protective bubble called the heliosphere that shields all the planets from high-energy galactic radiation. Every one of the stars we have mentioned, Proxima, Sirius, Vega, has its own similar bubble, jostling for space in the interstellar medium like balloons crowded together in a room. We live inside one of these myriad bubbles, protected by the steady outward breath of our home star as it carves out a safe, warm, quiet cavity in the harsh, high-energy winds that blow between the stars. The sheer emptiness of our neighborhood is difficult to truly comprehend without an analogy. If our sun were the size of a typical grain of sand, the nearest star, Proxima Centauri, would be another tiny grain of sand roughly 4 miles away, with absolutely nothing but microscopic dust and empty vacuum in between them. The next nearest star would be another grain perhaps 7 miles in another direction, and so on, creating a vast, terrifyingly empty desert, where these tiny specks of sand are separated by incomprehensible distances. This is why stellar collisions are almost impossible. The universe is almost entirely made of empty space, with stars being incredibly rare, lonely jewels scattered across a boundless, dark velvet fabric. We are isolated by a majestic, protective ocean of nothingness. Gliese 436 is a red dwarf about 33 light-years away that hosts a Neptune-sized planet with a truly bizarre, paradoxical characteristic. This planet is so close to its star that its surface temperature is scorching hot, yet scientists believe it is likely covered in a strange form of hot ice, water that is compressed by such overwhelming gravity that it remains solid even at temperatures that would melt lead. Furthermore, as this planet whips around its star, it is slowly evaporating, leaving a gigantic, comet-like tail of hydrogen gas behind it that is millions of miles long. A majestic cloud that would be visible as a grand smear across the sky if we could see it with human eyes. It is a world that defies our earthly intuition, where ice can be burning hot and planets can have tails like massive comets. Gamma Leporis is a binary system located about 29 light-years away that is currently speeding rapidly away from our own solar system. Like many stars, its motion relative to us means that in the distant past it was somewhat nearer and brighter in our sky, and in the distant future it will appear fainter as it continues on its way. Over millions of years, stars like Gamma Leporis drift closer and farther, slowly reshaping the subtle tapestry of the night sky. It reminds us that the constellations we think of as eternal are actually fleeting, temporary patterns that dissolve and reform over the long eons of time. Beta Comae Berenices is a star located just under 30 light-years away that is an almost perfect twin of our own Sun. It has nearly the exact same mass, surface temperature, and brightness as our home star, making it one of the best solar analogues in the entire sky. If you were to transport our Earth and place it in orbit around Beta Comae Berenices, we might hardly notice the difference. The sun in the sky would look and feel almost exactly the same as the one we have known all our lives. It serves as a reassuring mirror in the deep dark, a distant echo of home that proves that stars just like ours are out there, quietly burning with the same steady, familiar yellow light that fuels all life on Earth. Interstellar travel is often imagined as a fast journey, but realistically, it will likely be a multi-generational voyage of profound patience. If we ever send humans to even the nearest star, Proxima Centauri, using foreseeable technology, it might take centuries or even millennia to arrive. The people who arrive would be the distant descendants of those who left, born and raised entirely within the confines of a traveling ship, with Earth being only a legendary home they never knew. Such a journey would require a fundamental shift in how we view time and existence, moving from the hurried pace of a single human life to the slow, majestic, enduring perspective of a species slowly spreading smoothly across the deep ocean of the stars. It is a journey not of speed, but of endurance and continuity. Just 40 light-years away is 55 Cancri, a star that hosts a super-Earth planet that has become famous for its exotic nature. This world, 55 Cancri e, orbits so close to its star that its surface is a molten ocean of lava with temperatures reaching thousands of degrees. Because the system is incredibly rich in carbon, some early models suggested that the immense heat and crushing pressure inside this planet could have compressed that carbon into a vast, planet-sized core rich in diamond. Whether or not that exact picture is true, it is a dazzling, almost mythical concept. A world where the deep interior may be packed with crystalline carbon, glowing in the fierce heat of its parent star, illustrating that the universe is capable of forging wonders far more extravagant than anything we could dream up in fiction. Within our local neighborhood, there are likely many rogue planets that do not orbit any star at all. These are worlds that were violently ejected from their birth solar systems billions of years ago during chaotic gravitational interactions and now drift alone through the eternal darkness between the stars. They are cold, dark, and almost completely invisible to us. Silent wanderers that might occasionally pass relatively close to our solar system without us ever knowing they were there. They are the ultimate ghosts of the galaxy, untethered worlds sailing forever through the void, perhaps outnumbering the stars themselves, hidden by the very darkness that is their eternal home. They remind us that not every world has a sun to warm it. The light we see from these stars is a form of time travel, a direct connection to the past. When you look at Sirius tonight, you're not seeing it as it is now, but as it was over 8 years ago. The light hitting your retina left that star when different people were walking the Earth, when different events were making headlines. For more distant stars in our neighborhood, like Aldebaran at over 60 light-years, we are seeing light that left during a time when human history was in a completely different chapter. We never truly see the universe as it is in this exact moment. We only ever see a layered, majestic history of it, with deeper views into space corresponding to deeper views into the ancient past, all coexisting in our single present view of the night sky. If we could miraculously transport ourselves to a planet orbiting Alpha Centauri and look back toward our own home, our sun would appear merely as a bright, unfamiliar star in the constellation Cassiopeia. It would be one of the brightest stars in their night sky, a brilliant yellow-white point of light that would complete the W shape of Cassiopeia, turning it into a zigzag pattern that human eyes have never seen. From that distant vantage point, our entire majestic solar system, the giant Jupiter, the ring glory of Saturn, and our own beautiful blue Earth would all be completely invisible, lost entirely in the overwhelming glare of our sun. It is a humbling change of perspective to realize that to our nearest neighbors, we are not a complex system of diverse worlds, but simply a single, silent, bright point of light in their mythological heavens, just another star to wish upon. The dream of visiting these nearby stars is currently being channeled into a majestic project known as Breakthrough Starshot. The idea is not to send massive lumbering ships filled with humans, but rather thousands of tiny, gram-sized robotic probes attached to immensely thin light sails, which would be pushed by incredibly powerful laser beams from Earth to 20% of the speed of light. These grand fleets of tiny, silent messengers would take about 20 years to cross the majestic gulf to Proxima Centauri, and then another 4 years for their faint radio whispers to travel back to us with the first close-up images of another star system. It represents a new vision of exploration, where we do not conquer space with brute force, but rather sail gently across its endless oceans using beams of pure light as our cosmic wind. Stars are not just silent spheres of plasma. They are actually resonant musical instruments that constantly vibrate with deep, complex internal rhythms. The entire body of a star, from its dense core to its fiery surface, oscillates and quivers like a ringing bell, driven by the furious energy released in its heart, creating sound waves that bounce around endlessly inside it. While these sounds cannot travel through the vacuum of space to our ears, astronomers can detect these subtle vibrations as tiny, rhythmic changes in the star's brightness, a science poetically known as asteroseismology. By listening to this silent stellar symphony, we can learn about the hidden interiors of our neighbors, hearing the deep, resonant heartbeat of stars that have been burning steadily for billions of years in the quiet dark. Roughly 70,000 years ago, when early humans were just beginning to spread out of Africa, a small red dwarf known as Schultz's star passed remarkably close to our solar system. It grazed the outer edges of our Oort cloud, coming within less than a light year of our sun, perhaps appearing as a dim, reddish phantom that was briefly visible to the keen eyes of our ancient ancestors on very dark, prehistoric nights. It has since sailed away into the deeper dark, currently located about 22 light-years distant, but its gravity likely sent a gentle ripple through the sleeping comets of our outer system, a silent calling card that might still be slowly propagating inward today. It is a reminder that our solar system has had many silent visitors in its long history, passing ships that briefly shared our harbor before returning to the endless open sea. The sheer sparseness of matter in our local stellar neighborhood is almost impossible for the human mind to truly grasp. If you were to take all the stars, planets, moons, asteroids, and gas within a sphere 50 light-years across and compress it all into a single object, the remaining volume of that sphere would still be over 99.9999% empty vacuum. We live in a universe that is almost entirely made of majestic nothingness, a boundless silent void where solid objects are incredibly rare and precious exceptions to the rule of emptiness. This overwhelming openness is what allows starlight to travel unimpeded for millions of years, giving us the beautiful, crystal-clear view of the cosmos that we enjoy from the surface of our varied little world. Just as the moon orbits the Earth and the Earth orbits the Sun, our entire local neighborhood of stars is slowly orbiting the distant center of the Milky Way galaxy. We are all moving together at roughly 500,000 miles per hour, taking nearly 250 million years to complete just one grand circuit around the galactic core. The last time Earth was in this exact part of the galaxy, dinosaurs were just beginning to rise to dominance, and the next time we arrive here, humanity will likely be long gone or changed beyond all recognition. We are on a grand carousel that turns so slowly, so majestically, that whole geological eras pass in the blink of a cosmic eye, as we drift through the grand spiral arms of our galaxy. In the unimaginably distant future, our view of these nearest stars will be fundamentally altered by the impending merger of the Milky Way with the Andromeda Galaxy. In about 4 billion years, the night sky will not just be filled with our own local stars, but with the invading brilliances of 1 trillion new stars from Andromeda, turning the heavens into a spectacular, dazzling tapestry of light. While actual collisions between individual stars will be incredibly rare due to the vast distances between them, the gravitational chaos will fling many of our quiet neighbors into completely new orbits, reshaping the familiar constellations forever. It will be a majestic, slow-motion dance of two colossal island universes, combining to form a new, grander home for whatever silent worlds survive the graceful transition. Every atom in your body that is heavier than hydrogen or helium was forged in the crushing hearts of ancient stars that died long before our sun was born. The iron in your blood, the calcium in your bones, and the oxygen in your lungs were likely created in the same massive ancient supernova that also seeded the clouds that formed Proxima Centauri, Sirius, and all our other neighbors. We are, in a very literal sense, chemically related to these nearest star systems. We are all made of the same recycled stardust, different sculptures molded from the same ancient clay. It connects us intimately to the cosmos, a reminder that we are not just in the universe, but that the universe is inside us, sharing a common heritage with the brilliant lights we see in the sky. Our sun is somewhat unusual in our immediate neighborhood because it is a remarkably solitary star. The majority of star systems near us, like Alpha Centauri or Sirius, are binary or multiple systems, where two or more suns are locked in an endless gravitational waltz. Our single, lonely sun provides a much simpler, more stable gravitational environment for planets, free from the complex tug-of-war that can happen in crowded binary systems, which might occasionally fling planets out into the cold dark. Our solitary status might be one of the key reasons life was able to evolve here, undisturbed for billions of years, nurtured by the steady, uninterrupted focus of a single, devoted parent star. The habitable zone, that precious narrow ring around a star where temperatures are just right for liquid water, is incredibly slim compared to the vastness of space. For a red dwarf like Proxima Centauri, this zone is huddled so close to the star that it would fit entirely inside the orbit of Mercury in our own system, a tiny, thin ribbon of potential warmth in a vast, freezing expanse. It highlights just how rare and delicate the conditions for life as we know it truly are. A fragile, temperate shoreline between the roaring fires of the star and the absolute zero of the deep void. It makes our own lush, watery world seem even more like a precious, miraculous jewel floating in the endless dark. Gravity is the only force that has infinite reach, meaning that in theory, every object in the universe is pulling on every other object, no matter how far away. You are currently being pulled, ever so slightly, by Proxima Centauri, by Sirius, and by the most distant stars in the galaxy, just as your own tiny personal gravity is tugging back on them across the light years. While this force becomes infinitesimally small over such vast distances, it never completely reaches zero, meaning that everything in the cosmos is subtly, silently connected to everything else in an invisible web of mutual attraction. We are all woven together in a grand gravitational tapestry that spans the entire breadth of the observable universe. Because the distances to even the closest stars are so immense, any human journey to them would likely require generation ships. These would be gigantic, self-sustaining arcs, traveling oases of life that would drift through the void for centuries or millennia, where people would be born, live their entire lives, and die without ever seeing a sun or a planet up close. The crew that eventually arrives at Proxima Centauri would be the great-great-great-grandchildren of the brave souls who first launched from Earth, fulfilling a promise made by ancestors they never knew. It is a concept of exploration that transcends the individual human lifespan, requiring a commitment to a goal that only distant future generations will live to see achieved. Between us and the nearest stars, there are likely thousands of small, frozen worlds that we have not yet discovered. These are dwarf planets, similar to Sedna or Eris in our own outer solar system, drifting in the profound darkness far beyond the reach of our sun's warmth. They are silent, icy sentinels that inhabit the vast, lonely borderlands between the stars, too small to be easily seen by our telescopes, but numerous enough to form a vast, invisible bridge of frozen debris, linking our system to our neighbors. They remind us that solar systems do not just end abruptly, but slowly fade away into the dark, their outer edges mingling quietly in the deep cold of interstellar space. The speed of light, which dictates how fast we see our neighbors, also acts as a kind of cosmic preserver of the past. Because information cannot travel instantly, we can never know what is happening right now on Proxima Centauri. We can only know what happened 4 years ago. If that star were to suddenly vanish this very second, we would continue to see it shining happily in our sky for more than 4 years, completely unaware of its demise until the last of its light finally reached us. We live in a universe where the present moment is a strictly local phenomenon, and everything we see in the sky is already a memory, a beautiful ghostly echo of an event that has already passed. We are currently sailing through a region of space whimsically known to astronomers as the local fluff. It is a cloud of warm, tenuous hydrogen and helium gas, about 30 light years across, likely blown into our path by ancient supernova explosions millions of years ago. While it is incredibly thin, far thinner than the best vacuum we can create in laboratories on Earth, it is thick enough to have subtle effects on the magnetic fields of our solar system as we plow through it. It is a gentle reminder that space has weather too, vast, slow-moving clouds that we drift through over hundreds of millennia, changing the subtle environment of our entire solar system as we go. Ultimately, the study of our closest stars is a study of our own future and our place in eternity. In trillions of years, when all the bright, massive stars, like Sirius and Vega, have burned out and faded into darkness, the small, quiet, red dwarfs like Proxima Centauri will still be glowing steadily. They will be the last warm hearths in a dying universe, the final gathering places for any life that might still cling to existence in the incredibly distant future. They are the long-distance runners of the cosmos, holding onto their light with a fierce, quiet patience that will outlast almost everything else we see in the magnificent night sky tonight. And so, our journey through the glittering world of our closest star systems comes to a gentle close. We have drifted from the familiar warmth of our own sun to the dim red glow of Proxima, felt the brilliant white gaze of Sirius, and sailed through the silent, endless oceans of emptiness that separate these lonely islands of light. We have seen that our neighborhood is a diverse and majestic place, filled with stellar twins dancing in eternal waltzes, ancient travelers just passing through, and countless silent worlds that may be waiting for us to one day discover them. It is a neighborhood of infinite quiet, vast distances, and a beauty that has captivated humanity since the very first time we looked up and wondered what those tiny points of light truly were. If you happen to still be awake, that's perfectly all right. You can simply lie back, let the music keep flowing in the background, and drift in and out of the story at your own pace. But if your eyes are heavy, let the stories of these distant, silent suns and the gentle music carry you softly into rest. Sleep well. Good night.